Hello, Jonathan Wagner here with solidzymes.com, and today I want to talk a little bit about glutaraldehyde and show you how you can use it to immobilize enzymes or proteins on a solid surface. And for that I have here a enzyme carrier. This is a specially made material. It's polymethacrylate. It has a high surface area, large pores, big enough for a large molecule to go inside, and it has a high density of amine groups on the surface. I think this is made by Sun Resins, but you can get it from a number of different places, or you can look on our website if you need some ideas. But I have this carrier, and I also have a solution of glutaraldehyde. This is a 1% solution that I made by adding water to the glutaraldehyde I purchased. It comes as a 25% solution. And you'll notice that I'm wearing gloves and goggles and protective gear, and this is because glutaraldehyde can be hazardous. It works very fast, and I don't want it to fall on my skin or in my eyes and cross-linked proteins in my body there. So, I'm taking precautions. You should definitely take precautions as well when you're handling glutaraldehyde. But without further ado, let's go ahead and take this buffer off and add the glutaraldehyde. So I'm going to push my pipette tip all the way to the bottom and then draw off as much liquid as I possibly can. Put it in my waste and then add the glutaraldehyde. I'm going to add 1 ml of 1% glutaraldehyde onto this sample. It's about 4 times the volume of my beads. And I want to point out that there's a little bit of the buffer that I removed left here on the beads, and it's important that I didn't use a buffer such as tris, which has amine groups. I used a phosphate buffer. You can use phosphate or HEPEs, but don't use a buffer that has amine groups, because if you had, the glutaraldehyde would be reacting with that buffer right now instead of reacting with your surface. So I'm going to put this on the rotator in order to mix. I'm gonna let that mix for about half an hour, and the beads will turn brown, which is a good sign that the cross-linking is working as it forms those double bonds. And after that, what I'm going to do is I'm going to remove the glutaraldehyde the same way that I removed the buffer, except that I'm going to wash it about 5 times with 1 ml of buffer in order to remove all of the glutaraldehyde that might be remaining in the sample. And that's because I don't want any cross-links to form in between protein molecules in solution. I only want them to form between the surface and the molecules. So once that's done, I'm going to have my activated carrier sample. I'm going to add my enzyme. In this case, I'm going to be using lactase as a model enzyme to test this method. I'm going to let the lactase sit and immobilize on the carrier overnight for about 16 hours. Then I'm going to take it off, wash it again to remove the enzyme, and I'm going to measure the activity that I have on my surface to see if the immobilization went well. And then I'm going to repeat that experiment with all 30 of the carriers that we have here at SolidZymes. These are all carriers that have amines on the surface, and many of them are designed to bind proteins through ionic interactions, but I want to see which ones might be improved with a covalent interaction. So I'm going to go ahead and test all of these. I have 2 samples of each, with and without glutaraldehyde added. And I hope that if you're interested in learning which carriers work the best, you'll log into our website at solidzymes.com, look at our blog to see the final results. So until then, thanks for watching. I'll see you later.